The graph of function f is defined by this equation is shown in the xy plane above. If the function g not shown is defined by this function, what is one possible value such that f of a equals g of a? Again, every question on the SAT has a concept behind it. Once you figure out the concept, you're 90% done because the rest is pure algebra or just computation. So let's unpack this. At the heart of this question, it's saying there's an x value that we're going to plug in to both equations. And once you plug in that x value, the y values are the same. What that means is, if we have a function here, like let's say this is the x value, the function of f of x, and then we have an x value for the function g of x. By the way, they're just renaming x as a in here to make things complex, but it's really saying you plug in an x value named a, you get a y value. So what they're saying is there's an x value named a that we can plug into these equations. Once we do, we're going to get the same y value. Let's say, for instance, I'm making this up. Let's say if you plug in that a into the function f, your y value is 5. If you plug in a into the function g, your y value is also 5. That's all that's saying. So now that we understand that, let's go to the graph. We are given the graph of f of x. That's this blue curve that I'm highlighting now, in blue rather, I should say. And then that's a quadratic function. And then you can look closely and you say, this is a linear function that hasn't been drawn, so g is not drawn. Thankfully, we know how to graph linear functions. Remember y equals mx plus b? That's what we're looking at here. So when you're graphing linear functions, you're going to need m, which is the slope, rise over run. And for this graph, it's 1 over 1. Negative 1 over 1 to be exact. So that means we're going to go down 1 and to the right 1. And then you also need the b value, which is the y-intercept. The b value is incredibly important to us because that's our starting point. You always start on the y-axis where the graph crosses the x-axis. It's going to cross the x-axis at 10. So let's actually graph this graph. So starting at the y-axis, y-intercept is 10. We're going to go down 1 and to the right 1. However, be careful. Going downwards, we're counting by 1. So 10, 9, 8. But going on the x-axis, we're not counting. Each box is like 0.5. So be careful. We have to count 2 boxes to move one whole number. So from where we are, I'm going to go down 1 over 1. And I'm moving 2 boxes because that's what the x-axis is showing. Do it again. Down 1 over 1. Down 1 over 1. You can do this until the end of time. But let me just complete it real quickly. Just keep going down over 1. And you know, for any system of equations, your answer is where the graphs intersect. So if I join my linear function, the dots for it at least, there's 2 places where the graph crosses, where these 2 graphs intersect. There's this location here, and that point is 2, 8. And then there's this location right here, and that is 8, 2. So the question was asking, what is one possible value of a? Remember, a is the x value, such that the y values here are the same. So the answer can either be 2 or 8. Either one of these would be correct. Either there or there, where the graphs intersect. They have the same y value in that location. I hope that makes sense.